Hello again, welcome back to Introduction to Swift. Today we are going to talk about protocols. New topic, okay? So let's get into our slides. So from the previous class we looked at UIKit, so let's do a quick review. So out of the list here, which one of these would we use to display information that doesn't fit on the screen? UI view, UI label, UI scroll view, or UI table view? So probably scroll view and table view, right? Because they scroll, we can, have a list of things. If they have a lot of things on the page, we can scroll through them, and they can extend off the edge of the page. Okay, question number 2. Which view or control allows a user to enter a single line of text? So they have to enter the text in one line. Okay, so we got UI text field and UI text view. So actually UI text field allows us to enter one line of text. Text view lets us enter multiple lines or just display a multi-line block of text. You can also make these editable. Okay, which of the following allows you to execute code for a specific control event, and which allows you to access properties on a single specific view or control? Okay, so IB action is an action. So if we tap on something, or if we have a user interface element that issues an event, like when something happens, the action handles that event. So this is going to let us execute code. IB outlet gives us a reference to the element, the object, and we can set properties on it through its IB outlet. So you might need both for a button. Okay, awesome. Let's move on to the next slide here. So here we have the agenda. So introduction to protocols, we'll talk about protocols versus inheritance, and then we'll talk about protocols in Swift standard library. Learning objectives for today are create and use protocols, distinguish between protocol conformance and inheritance, and use protocols to describe properties and behaviors of a conforming type. Identify common protocols in the Swift standard library. So what are we trying to solve with protocols, right? Usually we build something and we start with class inheritance. So we build an object and then we think, this has some features that we want to share with other objects. So we make it a subclass and then we inherit that, across, or extend other classes with our subclass, right? And when we do that, we realize actually, maybe we have something that wants to share a property, but it doesn't want all of those properties. And then you make another subclass, and then you think well, maybe I want to inherit from 2 different classes, and that does not support it in Swift. So then you think, well, I have to make a subclass and then extend one class and then extend that class again. And you end up with a very complicated project, right? And unexpected behavior. There's a saying, I should have put this on a slide, but there's a saying where someone says, you wanted a banana, but you ended up with a gorilla holding a banana and the whole jungle. And that's kind of like they were talking about inheritance, right? And why inheritance is kind of a problem sometimes, right? And, maybe protocols kind of solve some of that. So it prevents tight coupling too. So what is a protocol? So protocols are another type in Swift, and you can't create an instance of a protocol. So if you define a protocol, you can't make a new instance of it, right? Instead, you use it as a blueprint. So protocols in Swift are very similar to interfaces in other languages, right? So the protocol just defines what properties and methods something should implement, but it doesn't say how to implement them. Okay, so essentially the protocol is like a way of saying that something matches a description that you're creating. So the protocol is a description, and you can say hey, I guarantee that this class or this object matches that description. Okay, so here's another description right here. Protocols are similar to contracts, right? So a contract guarantees that some terms will be satisfied, right? So if we say we create a banana and we guarantee that it's going to be yellow, and it's a fruit, then anybody that gets a banana will have those properties. Or if we create any type of banana, we can say that it conforms to the banana protocol. So every banana will be yellow, right? And be fruit. Yeah, let's see. So in Swift, we write a protocol like this. We say, protocol, full name, and then we say a full name. Anything that is a full name should have a full name that's a string that you're able to access. So this means you can't change it, but you can get it at least, right? And then we can say it should have a method called print to console. Okay, so protocol just says what the property is and its type and its access. Okay, so it doesn't say what the value is. There's no value here, right? Notice this isn't even it's not an optional either, right? And next, it says what the method is. So it says a full name should have a print to console method, but it doesn't show me that this takes any parameters, and it doesn't show me the implementation of that method or the return type. So that means that print to console doesn't take any parameters and doesn't have a return type. How and what is printed to the console, though, is up to anybody that conforms to the protocol, right? So any object that conforms to this protocol can print anything they want to the console as long as they provide a print to console method. Okay, so how would we use that, right? If you created a struct that was called a person and you made it full name, you made it conform to the full name protocol, it would have to implement the full name property or variable, right? So we have full name and it's a string, so that matches what we had up here, right? Next, it has to also implement an implement means it includes the code block. Okay, so up here we have print to console, no code block. Down here we have print to console and we've included the code block, right? So it has to implement the print to console method, and then it can do anything it wants here. Like how it prints to console is up to person, as long as person can print to console. So like, why is this important? Well, it's important because anything that we create that conforms to the full name protocol, we will know that we can access its first name property, and we'll be able to print it, call the print to console method. Okay. And if we want, our person could implement more features. So it could implement a last name, a full name, actually it's already got the full name, I guess. Or no, I guess yeah, that's a new one, right? It just confused me because it's got the same name here, but this one's uppercase, right? Yeah, so it can implement a full name property, and it has the print to console method. It could also have new properties if you want, right? But in order to be a full name compliant, right, think contract, right, it has to have this property that's a string and this method that doesn't take any parameters and doesn't return anything. Okay, so mini challenge, right? Create a protocol called perimeter that defines a read-only property called side that has a type of double. So you can stop the video and try that on your own. Okay, so how did you do? Let's walk through that. I'm gonna create a brand new playground here, and there we go. I'll make a brand new playground with Swift. I'll call it protocol example, and I'll put it on my desktop here. And let's see. So what we're going to do is, let me actually move this around here. So we need to make a protocol called perimeter. So we'll say protocol. And like classes and structs, we usually name protocols with uppercase letter, right? So I'm going to call it perimeter. And it needs to implement a read-only property called side. So I'm going to say var side is, and it says side should be a double. So I'm going to do side of double. And I'm going to include the curly braces on the end and say this is a get. If we say set, that means it's also writable. So get is a read-only or readable, and set is a writable. Okay? And there we go. So we got the perimeter property. So let's move on now. So here's another challenge. Let's implement perimeter with a struct that represents square and circle. So we're going to represent two structs, square and circle, but they should implement or follow the perimeter protocol. Okay, so let's try it on your own, and then I'll walk through a solution. Okay, so how did you do on your solution? Let's take a look. So I'll get Xcode up here, and I want to create a struct called square, and then I'll put a colon, and it's going to implement perimeter. Okay, and then I'll do another struct called circle, and it will implement perimeter. And at this point, I get an error. It says square does not conform to the protocol perimeter. And if I click on the little button here, it'll say, hey, do you want to put stubs in for the things that are missing? You can click the fix button and it'll add it, or you can type it yourself. So let's do it. So what does perimeter need? Perimeter needs to implement a side that is a double. So I'll say var side equals, side colon is a double. There we go, right? And then I can say over here, actually I'll do this one just for fun. I'll click on the fix button and you'll see that it just adds the same thing. Okay, cool. So there we go, right? Let's move on. So mini challenge. Add a circle and square to an array and print their perimeters, right? So the trick here is that I want to create an array, but since circle and square are two different types, my array should be type perimeter, right? Because then we know everything in the array matches the protocol. Give it a try. Stop the video, give it a try, and then we'll walk through it together in a solution. Okay, great. How did you do? Let's take a look. So I'm going to make a brand new array here. Let's call this var shapes equals, let's do colon is type perimeter, right? So it's an array of perimeter, and there we go, right? I've got an empty array, but it can take anything that conforms to the protocol perimeter. So we could create any class we want, but we know that all those classes will have a side property. Okay, so let's do that. Let's add that in here. Let's say shapes.append. We'll add a new element to our array, and I'll say new square, right? So I'll add a square here, and it should have a size of 10. And then maybe I'll do shapes.append circle, and you are going to have a side of 314, right? I feel like square should have a side of 4 and circle should have a side of 1, but you can put any numbers you want in there for now. Okay, so so there you go. How did you do? So what's interesting here is that the protocol doesn't say what something should have. So if we had special methods on circle and the calculate perimeter value method was, it's obviously going to be different than the calculate perimeter method for square, right? If we made classes and we extended them, that's a tougher problem. Here, all we're doing is we're saying that, circle is going to have a side property and a square is going to have a side property, and that's that. Maybe I misspelled that. Did it say sides with an S, like how many sides? Maybe I made a mistake, but anyway, the idea is the same, right? Okay, great. So let's move on, right? What I want you to do now is to work through this playground. So there's a playground here that has a whole bunch of examples of protocols in it, and so you'll work through those, and there's a couple challenge problems in there. So click the link here. I'll put a link in the video notes too, and you'll open up this playground here and you'll work through the problems in the playground. Okay, actually I have for some reason I have the if you see this and it doesn't show the rendered markup, you can go to the editor menu and choose show rendered markup, and then it should display like that, right? So anyway, so work your way through these problems and then come back and we'll continue in the next video.